Hello everyone. In this video we're going to talk about another derivative which is very important in energy markets, which are energy options. So this is very different from the previous derivatives we looked at, namely futures and swaps, in the sense that with the futures or with the swap you are committed to a given outcome, to a given payoff. So if the market evolves in a good direction or if the market evolves in the other direction, you always get the same result no matter what. With options, as the name suggests, you have the option to do something but not the obligation. So this is very different because it allows you to only use this derivative when it is profitable for you, when it is convenient. So this looks much more like an insurance. You pay a premium at the beginning and then you use it in the case of a disaster, in the case of the market evolving against you. Okay, so we're going to do this in 3 videos. This first video is going to review some basic concepts of options. The second video after this is going to look at the most important contracts in energy. And then in the third video we're going to apply these contracts to typical hedging strategies. All right, so let's start. Okay, so what is an option? First of all, an option is it's a contract between 2 counterparties that gives the buyer of the option or the holder of the option the right, but not the obligation, to buy a given underlying asset at a pre-specified price during a pre-specified period of time. Okay, if this that I just said is new to you, or it's not absolutely obvious to you, you should read these introductory chapters in whole, chapter 9 and 10. Okay, so I'm not going to go over this. I'm going to post some slides on the course web page. If you have questions, please ask. But I'm going to assume that you know what I just said basically. Okay, so what I'm going to do is I'm going to review what are options on futures. So the options that we typically use in the energy market are not simpler kind, are not the most straightforward options, because it's this slightly more complicated version of an option, which is an option on another derivative. So instead of being an option directly on an underlying basic security, it's an option on a future. So the definition is here. So for example, a call futures option is the right but not the obligation to enter into a long futures contract at a certain price at a certain date. So the underlying again is a futures. Okay, so we're going to use either this term options on futures or just futures options. Okay. So again, while the exercise of a spot option originates a transaction in an underlying spot asset, which you may think of this like a stock, for example, here what you get when you exercise the option is you get a position in an underlying futures contract. Okay. So the buyer of the option is the one that decides to exercise, the one that has purchased the option some time ago. Now it holds the option, so we call this either the option holder, or the option buyer, or the long option. So this is the counterparty that decides whether or not to exercise. And if he decides to exercise, the other counterparty in the option has to take the opposite position in the futures contract. Okay. So options in energy are mostly options on futures and options of the American kind, meaning that they can be exercised at any time. But I mean, these are what I said is that it's the more common version, but it's not the only version. So you can also have European options that are only exercised at maturity, and you can also have options on the spot directly. Okay, so we're going to look at all these possible versions, right? But why are the ones on futures, the options on futures, the more common? Because they have these advantages that you have here. They are on if you think about energy, energy is not the same the assets in energy are not the same as stock, for example. If you think about the stock, it is very clear. If I ask you what is the price of a share of Microsoft, you know exactly what is the price. But if I ask you what is the price of heating oil in New York Harbor, that's a little bit trickier. I mean, you don't know exactly where to get this price. So if you have an option on something which the price is not very clearly defined, where that everybody immediately agrees on, that may lead to problems. So if you have instead an option on the futures on that underlying, then the futures price, it's very easy to observe because it's trading on an exchange, and everybody can go to the exchange website and see what is the price of the futures, right? So that's the main reason why options in energy are typically on futures, because everybody knows what the price of the futures is. Okay. Okay, so what are the payoffs when we exercise option on a futures? So we have here the two possible versions of the option, a call or a put. Let's look at the call. So if a call is exercised, what are the payoffs for the option buyer, for the long call? Well, it takes a position in the underlying futures, a long position in the underlying futures. And at the same time, the call buyer receives the cash amount equal to Fs minus K. Fs is the last settlement price of the futures. So think of this, of the futures price yesterday. And K is the strike price of the option, of the call. Okay? And these two things together represent this payoff that you see here, where so what you have here is the maximum between 0 and the futures price minus the exercise price. But notice that this futures price is not the price yesterday. Ft is the price right now, at the moment when I exercise the call. Okay. So let's look at this with an example. I am going to use here examples that come directly from Hull. You have the reference here. This is not immediately the energy options that we're going to use in a couple of sections, but I think it's important to look at these options because this is not immediately obvious. So if you want to read more about how this works, you can go to Hull, to these examples, and read all the details there. Okay, so the example is the following. Suppose that a trader has one option on the September futures. Okay, and this is a futures on copper with a strike of 240 cents per pound. Okay, and one contract is on 25,000 pounds of copper. Okay, so notice if you have one call option, the underlying is one futures, and one futures is has an underlying of 25,000 pounds of copper. Okay. Okay, it's now August 15, and the futures price is currently 251. At the close of trading yesterday, so on August 14, the futures settlement price was 250. Okay, so let's suppose that I have the call and I decide to exercise it. Okay, so what do I get? What does the trader get? Two things. So one, long futures, and the underlying futures in this call is the September futures. So I get that. I get a long position in that futures. The other side of the call option takes the other side of the futures. So I become long futures, and the guy that some time ago sold the call option to me now becomes short futures. Right? At the same time, that guy also pays me an amount of money, which is this, what you have here. A cash amount equal to what? Equal to this definition that you have here. The previous settlement price minus the strike. So the settlement price yesterday was 250, okay, and the strike is 240. So that gives me a difference of 10 cents times the size of the contract, which is this 25,000 pounds, gives me $250. Okay, sorry. how much is this? So the previous settlement price was 250. The strike is 40, so 10 cents per. Oh, 10 cents, yes. 10 cents is $0.1. I was thinking about 1%. Sorry about that. So yeah, 10 cents is 0.1. So 0.1 is I have two zeros left here. $2,500. Yes, that's right. Sorry about this. So that's the correct number. $2,500. So I get these two things. All right. Now to show that this is equivalent to this payoff that you have here, which is the typical payoff of a call option, the current price of the underlying minus the strike. Let's add up the two things, right? So what I can do now, I have a futures, and I can, if I want, I can close the futures immediately, all right? So I'm long in the futures. If I decide to close the futures, my payoff is what? Is the price of the futures right now, 251, minus the previous settlement price, which is 250, okay? So 251 minus 250, 1 cent, okay? Now 1 cent, that's where my confusion was coming from. So 251 minus 250, that's 1 cent. 1 cent times the size of the contract gives me $250, right? $250 here. All right. So this plus the cash amount that I got from exercising the call, the total is $2,750, right? Which is exactly the same as this expression that you have here. Okay. So again, this shows you that the total amount that you get from exercising the futures option is given by this expression. So this was for the call. For a put, it's like this, and you have an example here that gives you these numbers to show that it works as the table suggests. All right. Okay, so now let's look at some properties of these options. This is a little bit confusing now, so I'm going to keep here the outline open just to make sure we understand what we're talking about, because we're going to be talking about a lot of names that look very similar. Okay, so we're first going to talk about European futures options, and then we're going to talk about American futures options. Okay, so everything we're going to say now is just about this kind where you only exercise the option at the maturity date of the option. Okay. All right, so within this European type, now let's compare futures with spot options. Okay, we can have these two types of options, either on the futures or either directly on the underlying spot. Okay, so the important result here is that when we have a futures that matures at the same time as the option, which for these energy options that we're going to look at is a very good approximation, because typically the option matures just before the maturity of the future, so they are very close. So we can approximate this by saying that it is the same. Okay, so if that is the case, which is what we have in practice here, then European futures call option is the same as a European spot call option. So within this European framework, a futures option is equal to a spot option. They work the same. They are the same. They are valued the same. Okay. So to see why that is the case, think about the payoffs. So if it is a spot option, the typical the payoff of a European spot option is given by this expression: the difference between the final spot price and the strike price, if that is positive, or if it's not. If it is negative, then 0. Okay. If it is a futures option, then as we have just seen before, instead of an S there, what I get is the future. So what I have here is the futures price at the maturity date. But if the maturities are the same, then we know that the futures basis has to converge to 0. So the spot and the futures price at the maturity date of the futures have to be the same, right? So that's what you have here. So what we're basically saying is that under these conditions, these two payoffs have to be the same. Okay. So again, a futures and the spot option are exactly the same. Okay. And this works for call options, and exactly the same argument shows you that it works also for put options. right? So that's one first important result. The second result is the put-call parity, again, for European options, for futures options. So the result is this one that we have here. This is the price of the call. This is the present value of the strike. This is the price of the put option. And this is the futures price observed today, discounted at the risk-free rate. Okay. Where does this relation come from? Well, because I can establish these two portfolios. Okay. You can look at the details. You can go through the details more calmly at home. But if you think about portfolio A and portfolio B, where portfolio A you have a long futures call option, so you have this part here. Think about what are the payoffs under these two scenarios at maturity. Either the futures price ends up below the strike or it ends up above the strike. Think what are the payoffs here. You just have to decide whether you exercise or not, and if you exercise you get something, if you don't exercise you get zero. So write that down here. Suppose you also have a cash amount like this invested at the risk-free rate. So if you have this amount invested at the risk-free rate, when you get here, the amount you have is exactly K. So let me just turn off something here. So you get here K. So if you add up the two payoffs, you'll see that what you get for portfolio A is this. It is K if the futures ends up below K. It is F if the futures end up above K. Okay. The second portfolio B, suppose you have a long futures put option. So you have this part here. You also have a long futures initiated at this current price and with this maturity. Okay. Notice that a futures at the starting point when you initiate it, it costs you 0 to enter into the futures, right? So there is no initial payoff. So you only have a payoff at the end depending on the relation between the initial price, F0, and the terminal price, Ft. Okay? And then you also have a cash amount equal to this, invested at the risk-free rate. Again, if you invest this at risk-free rate, when you get to this terminal date, you will have F0. So if you add up all the three outcomes, you will find again that this is the total net payoff that you have in these two states. So as you can see, portfolio B and portfolio A give you exactly the same payoff at day T. So therefore, they need to have the same price today. Again, notice that the futures, this middle asset here, does not enter into this equation because the futures costs 0 when you start. So that's the put-call parity for futures options. Okay. Now, let's think what this implies for European spot options. Okay. So this is the typical put-call parity for European spot options. Okay. It's very similar to the previous equation. Let me see if you can see both of them. You can't. So this is you cannot see this. This is the simpler version of the put-call parity. Notice that here you have just the stock price, or the underlying price, the spot price, sorry. Whereas in the futures option, what you have here is this expression that depends on the futures price. Okay. But as we have seen before, in this case that we are looking at, which is European options, where the futures contract matures at the same time as the options, we have concluded that the futures and the spot option are the same. Okay, they work exactly in the same way. They give you the same payoff in the end, and they have the same price. Okay, so that means that in these conditions, you can price a European spot option either through this standard put-call parity, okay, or since the spot option is exactly the same as the futures option, you can also price it through this relation here. What is the advantage? Why would you want to go through this through this alternative that looks more complicated? Well, because as we just discussed in the beginning, for energy contracts, it may actually be easier to observe the futures price than the spot price. So even though you may have a spot option, you may want to price it as if it was a futures option, just because you can easily observe the futures price. Okay. So this is an example from Hull. again, go to the book and see all the details if you have any doubts about what's going on. It's an option, not exactly on the energy assets we're going to look at. It's an option on silver. So it's a spot option on silver, okay, with these properties. And again, here it's the same advantage. Instead of using the spot price of silver, which is something that is not clearly defined, you're going to use the futures price on silver. Okay, this is the risk-free rate, and then you can use the put-call parity to find the price of the put option in this case. Okay. All right. So that was for European options. Now let's look at American options. All right. So again, an American option is an option that you can exercise at any moment. So first, this general result. Since an American option gives you everything that a European option gives you and something more, because you can exercise it at any point until the maturity date, not only at the maturity date, then you have this general relation that the American futures option price is greater than the European version. Okay. Okay, but now let's compare. Now within American options only, let's compare again futures options with spot options. Okay. When it was the previous kind, the European version, we concluded that a spot option and the futures options were the same. Now in this more complicated version, the American option, it's no longer that simple relation between the futures and the spot option. Okay. So here the relation between these two options, the futures and the spot, depends on the shape of the futures curve. So if the futures curve is increasing, then you get this relation between futures and spot options. Okay, and it varies depending on being a call or being a put. So the sign of the inequality varies. And then if the market is in the other direction, so the futures curve is decreasing, then you have this other relation here. Okay, so I mean, this is why this is like this. It's outside the scope of this course. This is just here for reference. Just the main point is just to say that the nice simple relation we saw in European options does not hold for American options, which is unfortunate because a lot of the options we're going to look at are American options, but that's the way it is. Okay. Likewise, the put-call parity for American futures options is not as simple as the put-call parity for European futures options that we have seen before. So now, instead of having a strict equality, now strict equality, it's not the right word. So instead of having an equality like we had before, now we have just these bounds between the difference between the call and the put price. Okay, so in the previous case, the European options, we could say if we knew the price of one option, we could know immediately the price of the other option. Now we cannot go that far. We can just say that if we know the price of one option, we can say that the price of the other option is within this range. Okay, and that's as far as we can go. Okay, so I'll stop here and then continue in a second video.